Hello everyone, welcome back to my YouTube channel. So in this video, I'll be explaining the concept of open circuit and short circuit test on single phase transformer. So it is very important from the examination point of view. So open circuit and short circuit testers on single phase transformer. The word itself says open circuit and short circuit test, which means that you are keeping secondary side of transformer open and you are calculating the respective losses or efficiency of the transformer, and also with the help of short circuiting the secondary terminal of the transformer, that is the secondary winding of the transformer, we'll be seeing the changes what and all it may happen. Okay, so you can see first what is the main objective of this particular concept, that is the parameters calculated from these testers, that is nothing but OC and SC test results, which are effective in determining the regulation and efficiency of a transformer at any load. Okay, and the power factor condition. So for any load and power factor condition, the efficiency and regulation of a single phase transformer that will be more effective with the help of this OCC test without actually loading the transformer. Okay, so that the main advantage of this method is that without much power loss, the tests can be performed and results can be obtained. So now we can observe the open circuit test, the circuit diagram. So single phase AC supply which is connected to auto transformer. Okay, so now to measure current flows to the primary winding, we'll be using one ammeter. To measure voltage across primary winding, we'll be using one voltmeter. To measure power in a primary side, we'll be using one wattmeter. Okay, but the secondary side which is open. Okay, so the LV side is connected to the supply side and the secondary side, that is a HV side, which will be open, so that the voltage across secondary side which will be same as E2. It does that will be same for first case also if we'll be using the ideal transformers. Okay, or else you can see now for this particular circuit the explanation you need to write, you need to know. So in simple word, I am telling you the experimental methodology for this OC test. So by keeping secondary winding of the transformer, uh, the supply which is given to the primary side of the transformer, slowly step by step with the help of auto transformer, you are applying rated voltage of primary winding of the transformer, and note down a no load current, no load voltage, no load power, that is I naught, V naught, W naught. Very simple. Repeat, by keeping secondary side as open, by varying the auto transformer till rated voltage of the primary side of the primary winding of the transformer, noting down the values of I naught, W naught, V naught. So in detail, the transformer primary winding which is connected to AC supply, the explanation of the circuit through ammeter, wattmeter, auto transformer, and the secondary winding of the transformer is kept open. Usually LV side is used as a primary winding, and HV side that will be used as a secondary winding to conduct open circuit test. And also the primary is excited by rated voltage which is adjusted with the help of auto transformer. Hence you have to measure the wattmeter readings, that is the input power, and you need to check ammeter and voltage values, that is a no load current, no load voltage. So the voltmeter which gives the value of rated primary voltage applied to the rated frequency, sorry, at rated frequency with the help of auto transformer. Hence sometimes a voltmeter may connect it across the secondary to measure secondary voltage, which will be giving you the same as the induced EMF, that is V2, that will be same as E2. When primary is supplied with a rated voltage, as a voltmeter resistance is very high, through voltmeter is connected, secondary is treated to be open circuit as voltmeter current is always negligible small. Okay, so in case of open circuit, a simple logic, by applying the rated voltage, noting down the value of I naught, W naught, and V naught by keeping secondary side as open circuit. Okay. So when the primary voltage is adjusted to its rated value with the help of auto transformer, then you will be noting down the reading of these all. Okay, that is nothing but you can see here V naught, I naught, W naught. That will be noting down. Then V naught is nothing but now rated voltage, W naught is nothing but input power. Similarly, I naught is nothing but input current, that is nothing but no load current. I1 is same as I naught. As a transformer secondary is open, it is on no load. So that current drawn by the primary is no load current I naught. It is having two components. One is I naught, sorry, one is IM, another one is IC. Whereas IM is given by I naught sin phi naught and IC is given by I naught cos phi naught, where cos phi naught is a no load power factor. Okay, so that we can observe the input power W naught for single phase transformer is given by V naught, I naught, cos phi naught. With the help of this, you will be getting the value of cos phi naught or phi naught, because W naught, V naught, I naught will be getting from the readings. With the help of that, you will be calculating phi naught. So if you know the value of phi naught, you can see from the readings you will be getting W naught, V naught, I naught. You are calculating phi naught, substitute I naught here, you will get the value of IM and IC. That's it. So can observe this for no load. Secondary side is open means there is a no load. Okay. So that as the secondary side is open, that is a current flows to the secondary winding is zero, that is I2 is zero. So that a primary current that will be same as I naught. The same thing I explained in a previous videos also. So that the transformer no load current, which is always a very small amount of no load current, hardly 2 to 4% of rated current. Okay. So as I2 is zero, copper loss is also zero, but iron loss will be present. Okay. So that as output power is zero, copper loss is very low. So that total input power that will be used as a iron loss. So the same thing, this power is measured by the wattmeter W naught, hence wattmeter on open circuit test gives only iron loss with a negligible copper loss for all the loads. So that W naught, that is a no load power, is nothing but iron loss. Vice versa in case of short circuit. So calculation with the help of open circuit test, we'll be getting the values of W naught, V naught, I naught from the readings. With the help of that, you will be calculating cos phi naught, that is W naught divided by V naught into I naught. We can call that as a no load power factor. Once after knowing the cos phi naught, you can get the IC and IM. Once cos phi naught is known, we can obtain IC is given by I naught cos phi naught, and you can get IM is given by I naught sin phi naught. Once IC and IM are known, then you can determine exciting circuit parameters, that is R naught. So from equivalent circuit diagram, R naught, which is given by V naught, that is a no load voltage divided by current flows to the no load resistor, that is what core loss component. V naught divided by IC. Similarly, X naught is given by V naught divided by IM. So these all parameters you're getting from the open circuit test. You can take the screenshot. So while doing calculation also, we will be knowing the value of W naught, V naught, I naught. You're finding cos phi naught, then you're finding I naught, then you're finding IM. With the help of that, we'll be finding R naught and X naught, that is V naught by IC and V naught by IM. So coming back to the short circuit test, the word itself says the secondary winding which is a short circuited, that is what you can call it as short circuit test. The second side, the same circuit diagram, but the secondary side is short circuited. So then in case of open circuit test, we are applying the rated voltage of primary winding, but in case of short circuit test, we are applying rated current of primary winding of the transformer. Then we are measuring current flows to the transformer at short circuit condition, voltage across the primary winding at short circuit condition, and power measured in a primary winding at short circuit condition. As the secondary winding which is short circuited, there is a flow of current in a load, that is I2, hence copper loss that will be present. As it is a short circuited, voltage across a short circuit is zero theoretically. Voltage across short circuit is very minimum practically. Hence, due to the lagging of voltage, there is no iron loss, only copper loss that will be present in a short circuit test. Okay, so you can see this. The secondary is short circuited with the help of thick copper wire. As a high voltage side is always a low current side, the condition explained in a equivalent circuit diagram. It is convenient to connect high voltage side to supply and shorting the low voltage side. In case of open circuit test, you'll be open the high voltage side and will be giving supply to the low voltage side. In case of short circuit test, the high voltage side you are giving the supply, the low voltage side you are short circuiting. Keep that in your mind. As a secondary winding is short circuited, its resistance is very small. Due to that, a maximum amount of current that will be flowing through the secondary winding. So that much of high current will be causing the overheating and burning the transformer. To limit this short circuit current, the primary is supplied with a very low voltage. That is nothing but you need to vary the auto transformer till that ammeter till that ammeter reaches or that reads rated current of primary winding of the transformer. Can see, to limit this short circuit current, the primary is supplied with a low voltage which is just enough to cause a rated current to flow through primary, which can be observed on an ammeter. Very simple. Hence, the low voltage can be adjusted with the help of auto transformer. Hence, this test is also called LV test. That is low voltage test or reduced voltage test. The wattmeter reading as well as voltmeter, ammeter readings which will be recorded. That is nothing but VSC, ISC, WSC. So here we are applying rated current with the help of auto transformer. So now the current flows to the windings which are rated current. Hence, the total copper loss is full copper loss. Means that there is no iron loss, only copper loss which is present. Hence, wattmeter reading is the power loss which is equal to full load copper losses as iron losses which are very low due to the short circuiting of the secondary side. Voltage across short circuit is minimum, hence iron losses are minimum. Where there is a voltage, there is iron loss. Where there is a current, there is a copper loss. So that WVSC short circuit power is nothing but full load copper loss. So calculations from short circuit test, you need to write first WSC, VSC, ISC. That is a short circuit power, current, voltage from the readings. Then you are finding cos phi SC. It is given by WSC divided by, so it is wrong. This is given by WSC divided by VSC into ISC. That is nothing but short circuit power factor. There, open circuit power factor. Then you are writing, or else you are finding copper loss. Copper loss, you already know WSC. With the help of that, you are finding R1E. ISC, you know, WSC, no. Whereas the copper loss is given by I square R. That is current flows to the short circuit is ISC square. R1 is the equivalent resistance referred to primary winding. Therefore, with the help of that, you can get the value of R1E is given by WSC divided by ISC square. Hence, once after knowing the value of, to find this R1E, or else you know this, the total Z1E is, we know that V equals to I into Z. Whereas for the short circuit voltage and short circuit current, the equivalent impedance that refer to primary winding is nothing but Z1E is given by VSC divided by ISC. Okay, You can also get a magnitude of Z1E, that is nothing but square root of R1E square plus X1E square. So that X1E, with the help of this, you can get the value of X1E. X1E is nothing but magnitude of Z1E square minus R1E square. So these are all the calculation that with the help of open circuit test, you will be finding R naught and X naught. With the help of short circuit test, we'll be finding the value of R1E and X1E to get the equivalent circuit. Thus, we get equivalent circuit parameters, that is R1E, X1E and Z1E. Knowing the transformation ratio K, the equivalent circuit parameters referred to secondary also can be obtained. So if the transformer is step-up transformer, its primary winding is low voltage, while secondary is high voltage winding. In short circuit test, supply is given to high voltage side and low voltage side is short circuit test. That you should know. This is about OCSC test. So with the help of open circuit test, we'll be finding cos phi naught, IC, IM, R naught, X naught. With the help of short circuit test, we'll be finding the value of cos phi SC, then we'll be finding R1E, then you're finding X1E, then we'll be writing the equivalent circuit. So with the help of OCSC test, you can find efficiency and regulation of the transformer, as well as you can find the parameters of equivalent circuit also. That is R1E, X1E, Z1E, or else I naught, IC, R naught, X naught, I1. That all you can get it from the open circuit test and short circuit test. Keep in your mind that in case of open circuit test, you are applying the rated voltage, then you are finding iron loss. In case of short circuit test, you are applying the rated current and you are finding the copper loss. The copper loss is negligible in open circuit test because there is no current. I2 is 0. The iron loss is negligible in short circuit test because it is short circuited, there is no voltage. Where there is a voltage, iron loss. Where there is a current, copper loss. Because of the constant voltage, you can also call that as constant loss, copper loss, or constant loss, iron loss, or core loss. The current which is variable quantity or else a varying quantity, hence copper loss you can call it as variable losses. So this is all about OCSC test of the single phase transformer. If you're having any doubts regarding this, feel free to write in a comment box. If you really like this video, kindly do subscribe and share maximum to your friends. Thank you and have a nice day.